Samira's
Hmm, Okay.
It is getting 0. To get. This is loading just once, that's the problem. When I click here, the load button, this is invoked. This is just, this shows the current image. the total number of images, right? Is the list. But when I change it, here it uses this one. So rather than using it here, why don't I use here? Because this also uses the current image index like this. I think this solves the problem. I'm thinking now, loading image, 0. Previous one is this one, 2, 3, 4, 5. Yep. Shows the index perfectly. I also press this, shows the indices. Sorry. Okay. Put some comments so that I can understand it later when I see this. This is buttons to label the image. It's variable. Dynamic based on the number of outputs. Yep. Another thing that I have to fix here. Let's make it a self.image info. Oh, not like this. Image info text. I'm not sure if it's too much. Because this should be nothing. And here I will just pass this. Used a new line in here to show more things. Just this. Oh no, okay. Do I need another one? Yes, I do. Not sure what this is, but I think that's what I'm trying to do here. Let's try it out. Load images. This one. Okay, it doesn't show anything. Changing the image info text, which I'm giving it back here. Is it too much to know? Of course. Okay, let's get it back to how it was. Move this, and let's just put this one here. As far as I know, it was one fig, and there was a text where right without any problems. Yeah, it's just pushing it away. What I don't want is just want the name of the image. Yep. Okay. It's getting the entire thing. So for that, I need to have this line is getting long, so that's why I need to, break it. Image name, base name, and let's see if I can just put this one here and if it works. Yep. Copilot, man, just making things easier. So you can see the image name here. Okay. I'm not sure the showing the folder name is necessary because you are selecting the folder. You're selecting the folder, so you know what the folder it is. So if it is necessary, we can try to edit it later. But what is necessary is the image shape. This is what I want to see. And can I not give this in index equals string? So image index plus image name should be plus string image shape. Why is the string here? I don't know. Let's put it here. Let's remove the what happened? Perfect. 28 by 28. But it should be the same for everything here, right? Image shape is getting this specific image. Yeah, it's right. Any other thing that I want to show? Not really that I can think of. Okay, so do I did the image information. Create a U design for the UI. Well, that's that's the thing that I don't want to do. I don't like designing. It's not my strong suit. Well, the next thing is to add this selectors for the model architecture, the loss function, and the optimizer in the settings frames. Yes, here. The fact is, like, I want to do this for many different types of machine learning as well as deep learning models. So the initial program, so that it runs, I'm trying to do it for the model that I know and very much use every day. It is neural network, a simple just artificial neural network, nothing else. So for the artificial neural network, you need few variables such as the input, the most basic type of neural net. If it's a network, then it should have like, I don't know, let's just draw it. And okay, yeah, so try to make it a bit bigger. Makes sense. Okay, so the most basic type of neural nets are, oh my god, I hate drawing like this. Anyways, yeah, okay. So the most basic, this is called input. That is the data points which are going into the entire model. This is a hidden layer. It's hidden because we don't actually know what's going on inside. We can get specific values from these nodes. We don't understand what these values corresponds to the real thing, because we know that the input here is the image and the output is the label or the classification or whatever you want to call it. But the hidden layer is something that the values in the hidden layer does not make sense to us. It just makes sense to the computer itself. So that's why it's called hidden, and it's like a black box model. The black box model meaning that we don't understand, like, if it's the model, we don't understand what's going on inside. Like, we don't fully understand. We just know that the input goes in and the output comes up. The inside informations are not really understood. So this is the most basic type of neural net that I want to design in here. So it should have an input and an output in the label. I have made, like, I coded the option to select the output, meaning, like, if this is the main page, they should have the main page text. And here I specified a drop-down menu to select output nodes. It's 5. I don't know why it should not be a drop-down. It should be to, the users can type in the numbers, because the output nodes can be many, but let's just keep it to a drop-down for now. So the other things that user should be able to select is the number of input nodes, number of nodes in the hidden layer, and the number of hidden layers, and how many nodes are in each of the hidden layers. So for simplicity for today, just let's keep the hidden layer to 1, and let's make 2 more options for the user to select the number of inputs as well as the number of the nodes in the hidden layer. So it's just a 3-layer network. Now, the issue that I have, like that I'm trying to think, is that the image or the input layer should be fixed depending on the shape of the data. Because whenever I train a neural network model, the input size cannot be whatever you want. It should always be fixed depending on some data. Like, for example, we have the MNIST dataset here, which are the MNIST digit dataset. If I use, let's use this. What's going on? Yeah, okay. So the MNIST dataset is in here. As you can see, this is just a digits datasets around, I don't know, 10,000 images of different handwritten digits. You cannot see it here. Different handwritten digits, 0 to 9, and the classification problem is to get the input is the image and the output is what the digit is. So that's what the neural network should be trained on. However, the problem that I'm trying to make you guys understand is that the images, all of the images, like 10,000 or so, are 28 by 28. Let me open a folder. Like, let's select the folder of 2. What I'm trying to see is, like, you see this? It says that's 28 by 28. The image shown in here is like really big because it's being scaled here. It's being scaled because if it's not scaled, it's going to be a very tiny image and very hard to label for a user. So it's being scaled. But in reality, these images are 28 by 28. So if I want to feed this data, like 28 by 28 data to this neural network, the input shape should be fixed. It's 100 and something. No, not the calendar. Oops. It's okay. No, it's not 100. It's 784 number of neurons in the first layer. And this is fixed because, like, for those of you who do not understand what 20 by 28 pixels is, so these are RGB images. Let me explain it to you further. But okay, so an image. Okay. Whoa. Yeah. Okay. So suppose this is an image. Images are made of pixels. And if we take a pixel, it usually has 4 values. R, G, B, and finally A. So each of the colors in your screen or any image that you see is a combination of these 4 values. Normally each of the things are of 0 to 255, comma 0 to 255, and you get the idea. Okay, I'm not sure about alpha because alpha is the the opacity. So I'm not sure if it's 0 to 255, but it still has a value, like limited value. So normally images are of like the shape. These are called like PNG images, or it should not be an R. A PNG where there is an alpha value meaning that there you can have a pixel with no, if the alpha value is 0, you have a pixel with no color in it, so it's just transparent fully. So each of the pixels have four different channels. We normally work with these three. In a computer vision model, we use three color channels: RGB, red, green, and blue. And for what do you call that? Grayscale images, which are of like black and white or anything in between, it has the color channel of one, just the intensity of brightness is just 0 to 255. It doesn't have any color. It's just, if it's 0, I guess it's black. If it's 255, I guess it's white. So that is the grayscale. It's just one color channel. So if we have an image where this amount of pixels is 28 and this side is also 28, meaning this image is square, and it does not have channels, just one channel, meaning the number of information that I'm trying to work with is 28 times 28 times 1, meaning if this was an RGB image, it should be 3 here. That increases our complexity further. So this amounts to 748, yeah, 84. 784 data points for the input. That's why it has like a, so if a user can select how many input nodes this model should have, it means that if he selects, like, it should have 784 images, 784 number of input for this network. If the user selects 780, because he has the ability to choose, where are you going to, from where you're going to subtract this 4, like 4 pixels, where are you going to take this away? Like, are you going to select this one? Are you going to select this one, or from the right to left, Y, from the like top right, Y, or in the middle 4, you just select and just get rid of Y. So we cannot do it randomly. Either what the user can do, like the user can do it. Let me clear this up. What the user can do is rescale the image to a smaller one. Suppose having 10 now in each side. Now, rather than having 700, it's just a 100 input that he or she needs to work with. So the problem with this is that the images that you see here have different values of gray. These are completely black, these are completely white. You see in between there are like different values. So these are critical information which will be lost if we like shrink the image further, which will not be inside of the neural network. Meaning that if we try to shrink the images so that like we have lower number of input neurons for the model, the model will not be able to have the most amount of information that it can have from the image. So the most we as a machine learning engineers, we need to think about the ways that we do decrease the data size, but not throwing out critical information. Let me give you another example of how anyone can think about removing data points. Like, for example, these parts, the the border parts, are not actually necessary because these are black. It's not contributing to the fact that the image is 2. It's just at the side. Because if the image were bigger than this, it will all be black. So why don't we shrink the image up to where there are no black parts? We can do it, but we have to do it for each of the image because these are not everything is not similar. Here, I'll show you. Okay, that's a bug. Okay, here, if you cut it from this side, we can cut it from this side because the left side of this line is black. But if we cut it this side for all of the images, this information is also being cut. So we don't actually know where it ends generally. And if we have to code a program which can detect the outskirts of this this image, so that all of the blacks are gone and we have a smaller image without losing information, that algorithm will also have its own time complexity, which increases the workloads further. So all in all, it's not a good thing to do. So normally these are the decisions that you need to do as a machine learning engineer or data scientist, so that you can reduce the data size without losing valuable information anyways. So what I'm trying to say is that the user should not have the ability to choose the input size, just the number of nodes in the hidden layer. That's all I think should be chosen, and the user should be able to see the difference of choosing a different amount of the different amounts of nodes. If he chooses one node in the hidden layer, it will have a dramatic impact on the model, model accuracy. Okay, right. So the user should not be able to choose the input size. The input size should be determined by the shape of the model. Now, the question: there are there are different ways that you can train a model, because we are using the artificial neural networks, just simple neurons, layers of neurons stacked on top of each other. There are other ways like convolutional neural networks, and now the diffusion models and stuff. Those are also can be used to train. So if the user select a specific type of network, like if I give the choice of selecting networks, like do you want to select the artificial neural nets for this problem or the convolutional? Let's talk about these two. So if the user can select artificial neural net AANs versus CNNs, then the model would be different. The input shape would be different. the model architecture will be different. So if we normally PNNs are used for image classifications. This and for this example, with the example that we are working on with the MNest dataset, the problem is very simple. The data points, 784 data points, are very low compared to like normal images that we deal with every day, because it has 3 color channels, and not obviously not the images that we do deal with every day are not obviously 20 by 28 pixels. It is on much higher resolution. So those needs convolutional neural nets rather than the artificial neural network. So if the user wants to train a model which an image classification problem with an artificial neural network, it's not actually advised, meaning that I have to like, code something for the CNNs in the future. But let's first focus on the ANNs. So the input shape of the ANN, the number of nodes in the input layer, should be determined by the shape of the input, meaning that if the shape is, it says the size. Okay, their shape. Let's try it. It's going to throw an error because there's no shape. Let's try it. Okay, for some reason, no object shape. Okay, there should be size. Let it be size, no problem. Let it be size. Okay, so the size is a tuple containing the width, the length, and the height, or the width and the height. The input shape should be the multiplication of those two. Okay, so let's change this to input nodes, and let's keep it 0 for now. I should have a model config file in here which saves the model shape that is being here. From the settings page. The settings page does not have the okay, but I'm going to like elaborate what I've been thinking. The users can select output. The n output nodes. The users will be able to select the n hidden nodes. So it's m. So these parts will be determined by the settings page. And saved into model config file. this, the input shape, X input shape is selected, we load the image. When we load the image, then it will be saved into the model file. Because the image shape can vary depending on the type of image that the user is uploading, the folder which contains the. Now, the problem with this is that if the user selects a folder which has a variable size length, that will be the problem. We should have the option to scale it. Should have the option to scale it. Current image is resized, right? It's opening the image again and here. It's like doing it twice, but I don't know. Changing the size here and then showing the image. That's just for showing the image. Hello. Mhm. Okay, let's get back to it. What I am trying to do now is to select the model architecture loss function optimizer. Don't think I need to select the model architecture. We okay, so everything will be solved if the user can select a specific size where all of the images that is found inside the folder will be resized to that specific size. That's it. That's the thing that I'm looking for. The user should also be able to select the input shape or the size, right? Apologies. Just here. Okay. For some reason it's input shape now. This I need to fix right away. Okay. So it has the nodes label and a combo box of values, right? Let's ask the AI. That's what I do. I just ask Copilot for everything. Create a field. Int field. Create int fields. You need to be very specific when talking to the AI. Create int fields for user to select height, width, and channel for input shape. That's AI. Okay. It is creating a combo box, which I don't think I need a combo box. Input nodes labels. The input nodes are created because it saw that there is like output nodes here and output combo, and now there's output nodes here creating this one as well, but this should not be it. I don't think we're going to use this one. Rather, we are going to use this, and this, the height, width, and the label channel. Let's see how it looks on our app. Okay, it's going to illegal annotation. What's the problem in here? I don't think that's a problem. Yep, it's not a problem. Okay, a lot of things in the settings now. Looks good. Now it looks good. So this is the specific thing that I should warn the user. Okay. No. Warn the user to select appropriate model architecture. No, input shape, length, width, for the model. So this is the problem, because if anyone gives like other things, like suppose this is 0, then the input shape will be 0, because that's the input shape of the model. It's determined by the height multiplied by the width multiplied by the channels, if there are channels. So if the user give it as 0, so the input shape is 0 and there is no model. Yeah. So okay. Channel elementary cell. Look. make default 1. Let's accept this and insert. Okay, let's see. Yeah, see, it is 1 now. Insert index 0, the string of 1. Okay, that's what it means. Self.channel entry. Channel label, channel entry. Okay, so there are like two things, meaning here is the channel label, this is the channel entry. That's what it means. Okay. So okay, so this is same for the what should it be default to? Default should be 224 because that's the industry standard for the, not the actually the industry standard, that's the, what do you call that, the basic, when we learned about the CNNs and we worked with the cats and dogs datasets, the basic was to use the 224 by 224 model. So that is what I can specify here, 224 for the width and also for the height, the channel. And this will show the, okay, yeah, that's the default. Okay, but should not be like this. Okay, now if okay, wait, canvas size should be 600 and here, why is it not, I don't know. Great. This is great. Great. I think I should also like data set file location. I did that. Use keyboard arrow key. ease to navigate through the images. That should be one. This one is easy because I just have to add the show previous image and the show next image. These are used by buttons, but I should have something to see if users like specific keys pressed. If so, that function is going to work again. That's it. Right. Okay, that's a lot of things going on. So when the label is pressed, like when this label page with the button, this button is pressed, a model configuration, meaning that the model architecture will be saved on the models page, right? Okay, now let's ask how to save a model architecture in a function. Let's ask what is the format of saving model architecture in a configuration file. I prefer the JSON one. I don't think you guys can see this. Here. These are more saving model architectures, but yeah, I would like to save it in a JSON file. Okay, to save only the model configuration architecture in a JSON file, you will use the following steps. Get config, json.dumps. It is not so that the Python file can access and create the file should have input shape hidden in less number of nodes in each hidden layer, output number of nodes in output layer, etc. Let's see what it says. One thing that I noticed in Copilot that it that's most of the things, which is certainly I can do it. Most of the things like I've seen, certainly. Yeah, this is the format that I've been. So let's try to say AAN. JSON. Um, I'll change it later. Yeah. Mm-hmm. Save it like this. Hmm. But for an ANN, like artificial neural networks, the simplest type of neural network should not have a 3D shape structure, such as this one. It should have the, not shape actually, it's just, let's call it input layer. Should have this, not, doesn't have an activation. Does it have an activation? Because it's just, yeah, this should be the units. The units should be, yeah. Okay, so show label page. It's going to take it to the start button. Different thing. Shared data. Controller.shared data. Okay, yeah, that makes sense. Just showing the output. Okay, good. Rather than writing it here, which doesn't actually have a specific, I can take it directly from the like, let's not write anything here. Just keep it 0 for now. This is getting out of hand now. Okay, just keep it 0 and 0. Oh no. Nothing, just 3 basic bare bone layers. And when you get it, you need to write it Loading from the model configuration. In your Python code that creates a model, we read the JSON configuration file. Okay, so I need the JSON for some reason. JSON to load the configuration file into a model config. Okay, so from the model config, I can get the input shape, the hidden layers, and everything. Okay, this is. This will create the model class. This will okay. I've got everything that I need in here. What? Okay, problem with that. I have the JSON. Now what I need to do is to with configuration.json. Not really, no. It's more like models slash ann.json as read f. Okay, so there's the configuration. Dot load. Okay. Now I want to change the existing data. And to change the existing data such as the output layer. That's another. Okay, yeah, got it. Here. Hmm. I get the shared data, the entire JSON file. Okay, so yeah, the entire config file, right? Problem arises is that dot dot slash should be the one. Okay. When we have the shared data, okay, not here, not here, not here. This is the oh no, not the comment this out. The config be the JSON file and the configs here. Output layer units. Up layer. Inside of the units, that should be the make it int. If I'm saving it, so I dump it. Dump the output layer units. This one, which will be taken from the shared data. However, why do I have to like take it from the main test when I can just take it from the Yes, this I can do it when the show label is pressed. Um, Yes, nothing here. Copy this. JSON node, okay. This should work. Firstly, the Tinker app, Tinker. Yeah, right. Will this work now? Weird. Is it because of the Windows? Okay, let's start with this one node. But it should save it as one. That's what I wanted to see. Indents equals 2. Indent equals 4. Okay, let's try 4. This is nothing. This is 1. Sets. Yep. But the problem when it's taking data, the shared data from output nodes, that is actually it is throwing the shared data as a JSON file. The JSON file should be okay. Yeah, this should be the one. Yeah, let's try it. First one is good. Let's select 3, label, and voila, we are good. Okay, everything works like a charm. Here is 3, and there's another thing that I want to see is this one. Yeah. So if I go next, and I label it as 2, this is also 2, this is also 2, this looks like a 1. So you can see this is, I'm not sure if I'm going to need it, but because the model is going to be trained directly, that's another point. But I guess for now, I think we can stop here. We did a lot. Okay, so I am going to stop here. So let's just commit everything. Update at readme.md, edit features. Just keep it like this. Stage commit and synchronize changes with the GitHub repo. So what I will be going to telling you guys are like welcome to participate and contribute to this if needed. Just pull out the request from the GitHub repo. The GitHub repo is on the description, and you can contribute anything. Like in the README, there are a lot of things to do. I'll be doing one by one, but you guys are like, welcome to contribute, and I'll like work on it when I have time, because I've got exams. I have less time in the weekdays. That's why I'm like, coming live on Sundays, and I'll try to come live on every Sunday with new projects. Or this one, like when it's done, I have a few projects in mind which are difficult, I'd say, but I think it'll be good working on the projects. I also have a game in mind, and we'll talk about it later. But for now, I'm going to work on this, like, every week, not every day. Like every day if I have time. I don't think I'll have time every day, but I'll work on it every week, like preferably Sunday, 1 or 2 hours if I have time again. But if after the exams, like this will be a daily thing. Anyways, so thank you for being in the stream, whoever are watching it later, and we'll see you in the next one.